So, gentlemen, delighted you're here. I think you're first up, Kurt, so you're going to start the presentation. So over to you.
Thank you very much, Markus. Hello from Austria, and thank you for inviting Tim and me to contribute to your webinar. As you probably know, we originally were supposed to meet a few weeks ago at our conference in Vienna, and part of that event was the IMI seminar on digital decor print given by Tim. Then about 10 days before the event, we learned that we will not be able to hold it at its original date in March, and we will have to postpone it. We were fortunate to find a new date quickly, and so now the conference will be held on October 19 and 20, and Tim's seminar on digital decor print will be held on October 21st at the original location, the Vienna Marriott Hotel. The technical program will remain unchanged, with very few exceptions due to speaker availability. About 1/3 of the presentations will be directly linked to digital print. There will be a presentation given by Thorsten Panke of Target on flooring, one by Duncan Ross of Avacatcam on software, one by Frank de Jonge of Adfos. And then there will be individual sessions like yours by FM Brooks, Rico and Hyman, one by Unilin and Agfa, and one by Egger and IPAC. And in addition to these presentations, you will hear about market update from AFRI, the interior furniture market from Fundamax, color trends from Zurteco, texture and material trends from SAPI, and finally, innovation, technology, and architecture from the University of Applied Arts in Vienna. The list goes on, and it's simply too long to list all presentations here. But if you go to our website, www.surfaces-conference.eu, you will see the full list. And as I already said, the workshop on the third day will be entirely dedicated to digital print in the decor industry. So without further ado, I would like to hand over to my colleague, Dr. Tim Phillips, Chairman of IMI Europe, who will give you a little glimpse of what you can learn at the workshop in Vienna in October. Tim, please.
Okay, hello everybody, and firstly to start with an apology because when we previously organised it for April, the seminar was the day before the conference. It's now the day after the conference, so I have an incorrect date on the screen. So the seminar will be on the 21st of October, the day after the two-day conference. So I apologise for that, and I will move quickly on to the next slide. We also have some other events coming up, just to briefly mention these before I move on to the seminar. We have an Inkjet Summer School in July. We're just in the process of moving that online for reasons you can understand, and we'll be announcing about that very shortly. We also have an ink characterization practical course, which we've also moved to October. It was going to be in April. And then there is the conference that we've just mentioned and our Digital Print Europe event, which again was going to be in the autumn. We're going to move that into 2021. So a lot of reorganization due to the events around the world at the moment. So we're working on that at the moment. For any more information about our events, see our website. So moving on to the seminar. So the idea of the seminar is to introduce inkjet technology, specifically for decor printing, and introduce that for people who are going to either or maybe already are using the technology within their businesses or are considering using it. And it varies from people who are hands-on technical people in the factories, all the way through to managers who, an understanding of how the technology works is very useful when you're just making business decisions about technology as well. And just to mention why the slides have changed to Catenary Solutions. So I have another company, which is a consulting company, which is talking about connecting technologies and markets. So that's the sort of introduction. So what I'm going to try and do in the next 20 minutes is to give an overview of what the one-day seminar or course is going to cover. So you can see here a brief outline of what the content of the course is. We're going to look at how inkjet technology works. We're going to look at inks, how you make inks, some of the challenges and opportunities in formulating inks for inkjet. We're going to look at printheads, what some of the key players are in the printhead market, specifically aimed at the decor market, who the important printhead manufacturers are, roughly how they work, and what their strengths and weaknesses are. We're then going to look at the really fundamental part of the technology, which is how do you form an inkjet drop, make it fly towards the substrate, land on the substrate, and what happens then. And that process is absolutely key to the way inkjet technology works, and it's key to all of the advantages and disadvantages of the process. So we're going to go into that in great detail in the seminar. We're then going to look at system integration. So how do you put components, print heads and motion systems and all those kind of things together to make a printing system? So that's relevant, obviously, if you're trying to do that, but it's also relevant for people to understand, if you're using a printing system, what are the compromises that had to be made in order to design it and build it. Then we're going to look at substrate interaction. So what does the ink do on the substrate, and what are the things that affect print and image quality? And lastly, look at specific decor printing challenges and opportunities. So that's the kind of overview of the one-day seminar. It's also an overview of what I'm going to say in the next 20 minutes, but obviously it will be much, much briefer this time. So why use inkjet? Well, it's in principle a very simple technology. It's very good at what we would call high-resolution printing, but what is effectively placing materials precisely onto a substrate. That's what you need to be able to do to print at high resolution. You can print at high speed, depending on the type of technology that you use. And crucially, it allows you to do digital printing. So I put it in quotation marks there. So by digital printing, what we mean is creating a pattern which is defined using software rather than hardware, as you do with flexo or gravure or offset printing. There you have some kind of physical entity which defines what you print. Any form of digital printing, whether it uses inkjet or whether it uses another technique, the thing that you print is defined digitally. That means that you can change it each time, for example. You can print short runs very effectively. You can print one-offs very effectively. And you can vary what you print as you print it. So there are all kinds of opportunities that you can do there. Inkjet technology is also very scalable. So we can choose basically how wide you make the printer, how fast you make the printer, and how many colors it prints, in principle, just by adding print heads. Now, it's more complicated than that, but the principle of that is very simple. You add more print heads, you add more capability. Last but not least, not necessarily relevant for the decor market, but it is non-contact. You print onto the substrate without actually making contact with it with anything other than the ink. That can be a weakness in some cases, but it's a way in which inkjet differs from some other techniques. So these slides always have a downside after the upside slide. So here's the downside slide. The reality of inkjet is very complex. It requires an understanding of physics, of fluid dynamics, of chemistry, of software, of mechanical engineering, all of these things, and they all have to work very, very well, and they all have to work together in order to give you what you want. There is a limitation of the materials that you can deposit, and that's limited in a number of ways. It's limited by viscosity. Inkjet printheads work with low viscosity fluids, and that is a limitation. They're limited by particle size. The fact that you have relatively small nozzles that the fluid has to be jetted through does limit the size of particles that you can use. And it's also limited by materials compatibility. So there are quite a few materials that are just too corrosive, for example, to be used with an inkjet printhead. In comparison with some of the other techniques that I've mentioned, the ink behavior on the substrate can be quite substrate dependent. So whereas a flexo machine can be quite independent of what it prints onto in terms of print quality, if you try to do the same thing on the same range of substrates with inkjet, you'll find very different print quality depending on the different substrates. And again, that's a challenge. And that's really because it's all about the interaction between the ink and the substrate. Also, drying time can be an issue for inkjet, particularly when you're trying to print very fast, and particularly when you're printing onto substrates that don't allow you to dry very quickly. And last but not least, and this is very much an issue for anyone that's used an inkjet printer, all the way through from desktop printers through to large industrial systems, the reliability of those printers is limited by the ink and printhead interaction. So you have to be completely on top of that interaction. We'll come back to that a little bit later in order to get the best possible reliability. So just briefly, there are two basic types of inkjet. Either continuous inkjet, where you create drops all the time and you decide whether or not those drops are going to go and land onto the substrate. You can see there on the left. Or drop on demand, and the name very much tells you what happens. You create a drop when you want to create a drop, and then all of those drops that you create land on the substrate. So the one on the right, drop on demand, is really the one that we're going to talk about here, although there may well be possibilities for continuous inkjet in decor printing. And that drop on demand inkjet then divides into two types, or two main types, depending on how you generate the drops. So the one at the above in the diagram there, thermal inkjet, where you create a drop by heating the ink up. And that's the HP technology, which is used on the desktop, but also in some industrial systems as well. So it does have some relevance. But again, the vast majority of the systems that we're talking about are piezo drop on demand, the one in the lower half of the diagram. And there you're creating a drop by some kind of mechanical deformation of an ink chamber in response to an electrical signal. So you use a piezoelectric material, and as the diagram kind of shows there in principle, what you do is you add an electrical signal, and that squeezes the ink chamber in some way. It could be that way or that way, and that generates an ink drop. So that's an extremely brief introduction to inkjet. We're then going to look at ink types, again, very briefly. So one way of determining ink types is the carrier. So the main component that the ink is made of that then contains the colorant or whatever other material it is you're trying to put down. You can see 5 different types there based on those types of materials. The one that's most relevant for decor printing is water-based, but solvent-based materials may be relevant as well. And in fact, some UV curable inks are used in some kinds of decor printing as well. So that's, again, something that we'll go into a lot more detail, how you make those types of inks and how they work in an inkjet printhead. Complexity, and the reason why I touched on this is because it's sort of relevant to something that I'm going to say briefly later about cost. To get the light fastness from decor print that you almost certainly need, they tend to be long-lasting prints that are used in things that are going to be in your home, for example, for a long time. You tend to need to use pigment-based colorants. The formulations for pigment-based inks are much more complex, and they're complex because of pigments. They're also complex because of being used in inkjet printheads, and that inevitably means that they cost more to develop and they cost more to make. And this has an impact for the final cost of the ink. And this is very relevant, and one of the questions that's always asked about inkjet inks by people that are used to using flexo inks, for example. Flexo inks are extremely cheap. Why can't inkjet inks be that cheap? Is it just that the ink manufacturers are making excess profit? And we'll try and explain that that's not the case, that there really are more complexities and higher materials costs that go into those inks, and that's why they tend to cost more. And so, as I mentioned, pigment inks, they are what you really need for high light fastness. You have to use them in UV curable inks, as we mentioned, because otherwise they get bleached by the curing method. But they are more difficult to make inks out of, and they require a more complex formulation. Briefly onto printheads. So these are the kind of mechanical part that's at the heart of the inkjet printer. The printhead selection is very much a fundamental part of choosing your system, either choosing the system that you're going to buy that's already been built, or if you're a system builder, choosing which printhead you use in order to create your system. it's a choice you have to make very early on in your system design, and it's also a choice that locks you in very much. And the reason why the picture of the screen is there is because you can certainly realize, and I've had experience of this myself, realizing that several years into a development process, thinking, did we perhaps make an incorrect printhead choice? Because if you have, it's very, very difficult then to change, because it affects the ink choice that you've made. It affects the way the printer has been designed, both from a software point of view and a mechanical point of view. And trying to change that is very difficult and very expensive, and introduces time delays. But the print quality that your system will give is really only known for sure until you've built it. So that's a real fundamental dilemma at the heart of every system design process that's gone on in the last 20 plus years of development. And when you see a lot of grey-haired people in the inkjet industry, this is why. This is one of the reasons why. There are lots of other ones as well. But so we're going to talk about piezo DoD, as we mentioned. That's the key technology that we're going to talk about, and we're going to go into more detail about that in the seminar. The main players in the market that are relevant to the decor printing industry, so really talking about printing water-based inks with high resolution and high speed, and probably on a very wide system as well, so with a large number of print heads. These are really the key manufacturers that are of interest here. So from left to right in terms of the pictures, we've got Kyocera, we've got Fujifilm Dramatics, we've got Ricoh, and we've got Konica Minolta. So again, in the seminar, we're going to look at some of these things in more detail, how they work when they're put together in a large number of print heads in an array to make a large printer, and all sorts of aspects like that as well. And this is just one picture to really cover a hugely complex and hugely important part of inkjet, the actual ink jetting process, so the drop formation process. And this is just an example in a test printhead, basically. But it's a very nice picture showing an example of drop formation working very nicely. So a single jet of ink is ejected from the printhead, and it turns into a single drop of ink going off towards the substrate from left to right. So that's how it works on a good day. On a bad day, it really doesn't work like that. And again, that's something that needs to be understood, because as I mentioned near the beginning, the ink and printhead interaction, in other words, how the drop is formed from the printhead, is completely fundamental to the way the technology works, and therefore how it doesn't work as well, if that's the case. So I mentioned system integration, and again, I'm just going to give a very quick overview of this. This is a picture from Xenia, where I used to work, but it's a very nice way of summing up how the inkjet technology works. So you have a circle there. I'm sorry, I can't point at things on the screen, but you have ink chemistry, you have the print heads, and we've talked about the interaction between those two. Then you have the motion system at the bottom, and that's the thing which either moves the print heads or it moves the substrate, or in some cases it moves both. But what it does is it tries to ensure that the ink drop lands in the right place on the substrate. And then, of course, you have the substrate. There are all sorts of challenges with those four key parts of the inkjet circle, and they're connected together by various things. And as I mentioned earlier, they can be fluid dynamics, they can be chemistry, they can be electronics and software, they can be mechanical engineering. All sorts of aspects need to work together. And just that one brief picture shows you all sorts of different things that need to interact together in the correct way. And if any part of that circle is broken, you have a problem that needs to be solved. Another way of looking at something similar is to look at that as a process triangle. So you have the ink with all of its parameters, you have the substrate with all of its parameters, and you're hoping to deposit that ink onto that substrate. And the thing that you use that is the printing system at the bottom right, and that has parameters and constraints and limitations and things like that as well. And so you need to understand how these things work in a complete triangle with the process at the center. So fundamentally, the interaction between the ink and the printhead and the substrate has to be right. The ink drops need to land in the right place at the right time every time, pretty much, in order to make this work. And we're talking about billions or tens of billions of drops needing to do that with reliability. We have to build the machine robustly and soundly. And the last point there, we need to define the output. So what we're designing is a process. What we're designing is a way of producing a printed decal pattern. The machine is the way that you achieve that, but what you're doing is designing a process. So again, that's a sort of very, very quick way of looking at system design. Then we're going to look at surface behavior. So this is just a very complicated slide to just to mention how complicated this is. So we're talking about drop behavior. So this, at the bottom, you've got a drop that's landed onto a substrate. It's then going to do a number of different things. It might absorb into the substrate. Some of the carrier, the water or the solvent, may start to evaporate. The components in that system may evaporate at different rates and give you changes in composition in that drop while it's drying. You may get precipitation of things that were previously soluble becoming insoluble in that drop. So there's all sorts of things that can happen onto the surface, and that's just for a single drop. So there's another way of complication if you add extra drops onto the surface at the same time, and of course you are going to be doing that with printing. The interaction between those drops gives loads of extra complications as well. So image quality, which we said is fundamental. So the goal is to create an image that looks good. And by good, we mean something different depending on what the application is. But fundamentally, we're trying to produce something that passes some sort of customer test. Does it look as good as you and your customer hoped it would? And that's obviously a qualitative test in almost all cases. But related to that, there are very much quantitative parameters about do the drops land in the right place? Have they got the correct size, the correct shape, the correct sharpness? Does the spread of the image on the surface work in the way that it was intended to? And behind that, of course, is all of the technology in terms of were the drops ejected at the right size, at the right frequency, at the right time, and all of those sorts of things. So again, a relatively simple slide summing up a complicated process. And what affects print quality? Well, the short answer is everything affects print quality. Again, if you come away with one thing from this short introduction, it's that Inkjet requires interaction between different types of technology. So all of these things on the screen are the different aspects of the Inkjet printing system. And by system, I include the ink and the process and the substrate as well. The interactions between those affect image quality as well. So we need to be in charge of all of those things. And so just for examples, things to do with the printhead affect print quality, the size of the drops, the uniformity of the size of the drops, the straightness of the ejection of the drops, for example. The ink we've mentioned, the ink printhead interaction, so the drop ejection, which I've mentioned, the ink and substrate interaction, so what happens to the drops on the surface, how the motion system works, how well the printheads are aligned to each other, how you process the image in order to turn it into a set of instructions to produce drops, how the printed image is dried and post-processed, which is a very key one for decal printing, for example, where there is a complex process that's going to occur after you've printed this image. So all sorts of factors that are affecting the print and image quality. So how does this apply to decal printing specifically? Well, generally speaking, for the laminate process, which I guess is the key one, there are examples of other ones as well, but just focusing on that one for today. We're talking about producing or using a very wide single pass inkjet system, printing a large amount of paper per second or per minute. We're talking about using aqueous pigment inks, and they have their own challenges, which we'll go into more detail in the seminar itself. We need to produce suitable print quality onto laminate paper. And laminate paper is a quite absorbent paper, so just producing a suitable image quality onto that paper is a challenge for inkjet printing. We need to ensure that that print is compatible with the existing lamination process, because in most cases that's a given. It needs to fit into the existing lamination process. It needs to be industrially reliable, so it needs to work day after day, week after week in the factory. That's what people are used to from other types of printing technology. There needs to be a realistic cost structure. So by that I mean both the cost to buy it, but also the cost to run it. And different to Flexo or something like that, a very key part of the cost to run it is the ink cost. It's a very small part in traditional printing, generally speaking, because the inks are very cheap. But for inkjet, it's the major cost of running a printer. And that needs to be understood, whether that can be tolerated within the cost model you've got, whether there are opportunities to reduce that cost and still get the quality of product that you're trying to do. So all of those things are challenges.
I'm going to ask you a quick question. I mean, it's an obvious one to many, but how often I hear that projects sometimes go a little wrong when the fundamentals aren't addressed at the start. So it's really important, isn't it, to get the right ink selection, the right head selection, and really think through that at the beginning, almost independent of any relationships or preferences you might have. Because I often hear, I don't know if you two would agree, I often hear that projects often go wrong when those things aren't addressed properly at the beginning. Is that right, Tim?
Yeah, that's right, and that would apply both at the development of a printer or a solution stage, but it also very much applies at the we want to try inkjet printing. Let's go out and buy a printer and try it in our factory stage as well. So we had a very nice, very interesting talk from a user from the decor industry at one of our conferences a couple of years ago. I know the inkjet technology people that were sitting there were surprised how many things that they were learning about inkjet technology and its limitations after they'd installed an extremely large, extremely expensive inkjet printing solution into their factory. And it's very easy from the technologist to sort of say, oh, well, we could have told you that wouldn't work. But if you're in a factory and you're hearing about digital technology and thinking, well, we need to try this, we can't be left behind, we need to try it. Obviously, learning on the job is one way of doing it, and what they've learned is great, and they're producing amazing stuff with what they've got. But understanding more about the technology and its limitations maybe could have helped to streamline that process, to smooth that process out.
Yeah, and this course really helps people understand that to avoid the problems later on, because fixing problems later on costs far more disruptive, and basically it loses money, isn't it? It's more likely to lose money and waste time.
Yes. You know? Yes, and I mean, everybody knows that hindsight's a wonderful thing, and hindsight's so much easier than foresight. But you know what we're trying to achieve, and I guess this is a mission for IMI Europe generally, is help people to understand the technology so that they can use it more effectively and therefore get more out of it.
So almost you're providing some hindsight in this session. Well, yeah, that kind of thing, really. You know, benefit from mistakes that other people have made. You know what I mean? Yeah.
Well, I think that, yeah, I mean, anybody who's been in the inkjet industry for more than a few years has lots of examples of mistakes that other people have made, which is great to maybe laugh at other people, but what you also need to do is try and learn from those.
Exactly that.